So, students, today we have to discuss what is electrolysis and how does we produce the different substances to the electrochemical reactions. They are also known as redox reaction. So, the definition about the electrolysis is the chemical process or chemical change bring about by the electrical current is used. The process in which electrical current is used to bring about a chemical reaction is known as electrolysis. Conductor, basically a metal, an element, can transmit the electric current due to the presence of free electron. But when electric current is passed through the conductor or any metal, there is no chemical change happening. No change in its chemical composition. All metals are the conductor of current as well as graphite is a non-metal, but it can pass electric current too due to the presence of free electron. Non-conductor are the non-metal substances. They cannot pass current in the solid or liquid state, but conductor metals can pass the current in the solid as well as molten state. Electrolyte basically ionic compounds. When they heat it, they change into molten state. When they dissolve in water, they produce aqueous solution. And due to the presence of ions, free mobile ions, electric current can change their chemical composition. Like sodium ion can travel towards the cathode, chloride ion can travel towards the anode. So the chemical changes occur in the electrolyte, but not in the metal, not in the conductor. Non-electrolyte are organic compound like distilled water, ethanol, sugar solution, benzene, kerosene oil. They are non-electrolyte, so there is no chemical change occur when electric current is passed through them. Electrodes are the metallic. Electrodes are the metals. They can be connected to the external circuit like battery, positive and negative plates. So cathode and anode are collectively called electrodes. How many types of electrolytes we have in our universe? It has been discussed so many times during the acid-base topic. Strong electrolyte, strong acid and strong bases, weak electrolyte, weak acid and weak bases. We know that a strong electrolyte can pass more current, so the brightness of the bulb is much more greater than the weak electrolyte because due to the presence of more ions in the solution, so the bulb is bright, but the less ions are present in the weak electrolyte, so the brightness of the bulb is low. While there is no passage of current through the non-electrolyte solution at all. We have three strong acids. They are called strong electrolyte HCl, H to the 4, HNO3. Similarly, strong bases we have eight: lithium, sodium, potassium, rubidium, cesium, calcium, strontium, barium. These eight metals combined with hydroxide, they are called strong bases as well as strong electrolyte. Rest of the H containing compound are weak acids. Rest of the OH containing compound are called weak electrolyte or weak bases. Now, we have to move the first case of electrolysis. The process of electrolysis. When a compound is dissolved in water or in the molten state, it splits up its ions. Not electron, ions. Electrolytes have positive and negative ions, while cathode and anode are the metallic plates which are connected to the respective terminal of the battery. The large line should be the positive anode, and the smaller line is called cathode, negative. The positive ion moves toward the negative electrode, which is called cathode, and are called cations. Here, here, gain of electron means reduction takes place. Negative ions move towards the positive electrode, anode, and are called anions. Here, at anode, loss of electron means oxidation occurs. Cations are mostly metal ions like copper, sodium, silver, leads, all metals, they are definitely positively charged. Anions are mostly non-metal ions because they contain negative charge. So these positive ions, they must travel towards the cathode when the electric current is passed through the solution or electrolyte, while the negatively charged ions, they must travel towards the anode positive plate. At cathode, cations gain electron, reduction takes place, just like that. Copper ion before reaction are positively charged. When they accept electron, they produce copper metal, while negatively charged chloride ion lose their electron, means loss of electron, oxidation takes place at anode. So chloride ion change into neutral. In short, positive and negative ions change their species into the neutral condition through electric current. This process is known as electrolysis. Both type of ions are discharged at the electrodes. So the positive, negative ions, by gaining or losing the electron, change their species from positive to negative or positive to neutral or negative to neutral. This is called electrical decomposition, is known as electrolysis. The most important topic for the electrolysis is preferential discharge of the ions. We know that here is the reactivity series, reactivity decreasing down the series, not in the group. Cesium, potassium, sodium, calcium, magnesium, they are positively charged ions. So, but when electric current is passed, we have two different types of ions in the solution, positive like magnesium positive ion or hydrogen positive ion or any positive ion above the hydrogen. When electric current is passed, the upper ions which are upper on the hydrogen in the reactivity, they never be discharged in presence of hydrogen. Just hydrogen ions should be discharged at cathode. But if we have two different types of ion, number one hydrogen and number two below the hydrogen like copper and hydrogen both are here, then when electric current is passed, now copper ions must be discharged at cathode because reactivity decreasing means loss of electron is difficult, but gain of electron is easy. So upward to downward, this is decreasing the reactivity means reactivity decreasing means loss of electron is difficult, but gain of electron is easy or visible. And the negative ions like anion, sulfate, nitrate, these two ions cannot be discharged at any cost at anode at all because sulfate and nitrate cannot be decomposed through the electric current. But we have two different ions from the solution like chloride and hydroxide. So beta, if chloride ion have more concentration, then chloride ion should be discharged at anode in the form of chlorine or bromine or iodine. But if salt contain less amount in the solution, so the chloride, bromide, iodide ion concentration is less, then the water molecules over it, then hydroxide ion must be discharged at the anode. As a result, oxygen gas is produced. So beta cations are always discharged in the order of reactivity, no doubt. Anions follow this order, but in concentrated solution, halogens are discharged first. Here, hydroxide ions cannot be discharged at all. But aqueous solution, halogens cannot be discharged. Then oxygen gas is obtained by the discharge nature of hydroxide ion at anode. Now, in the next lecture, inshallah, we have to discuss electrolysis of molten lead to bromide, concentrated and dilute solution. It will be discussed in the next chapter. Allah Hafiz, we have to finish our class right now.